Assalamu alaikum, students. Today we shall talk about another important oxidation reaction that is called Swern oxidation of alcohols. We know that alcohols may be classified into primary, secondary, and tertiary alcohols. What happens in this reaction is that the primary alcohols, upon this Swern oxidations, they are changed into aldehyde. No further reaction occurs. Reaction stops at this stage. This is the beauty of Swern oxidation, that primary alcohols changed into aldehyde upon Swern oxidation. Secondary alcohols, upon Swern oxidation, they they are changed into ketones, while the tertiary alcohol, when they undergo the Swern oxidation, they are resistant toward oxidation. No reaction occurs. So we shall study that why tertiary alcohols are resistant toward Swern oxidation, while the primary alcohols, they are changed into aldehyde, while the uh, secondary alcohols, they are converted into ketones using Swern reagent. What is Swern reagent? Swern, it utilizes DMSO. What is DMSO? Dimethyl sulfoxide. This is DMSO, a very common and popular solvent, and it's very cost effective solvent. DMSO, dimethyl sulfoxide. It also utilized oxalyl chloride. Oxalyl chloride. What is the structure of this oxalyl chloride? This is oxalyl chloride. You can shortly write it like COCl whole twice. So this is oxalyl chloride. You also utilize a base such as triethylamine, triethylamine, or any other tertiary amine like diisopropyl methylamine. What is diisopropyl methylamine? Diisopropyl methylamine. This is right. So any tertiary amine. And the last condition is that the reaction should be carried out at nearly or below minus 60 degrees Celsius. So the combination of these three chemicals is known as Swern reagent. I repeat, that Swern reagent consists of three main chemicals. The first one, DMSO, dimethyl sulfoxide. The second one, oxalyl chloride. The third one, any tertiary base such as triethylamine. Mostly in most of reactions you will see that the people have utilized this base, triethylamine. And the fourth is the condition, that is the reaction should be carried out at nearly or below minus 60 degrees Celsius. This is very important. So this is one reagent. So when alcohols, I write here an example. This is an example of primary alcohol. So upon reaction with Swern reagent, DMSO, oxalyl chloride, triethylamine, and minus 60 degrees Celsius temperature, this compound undergoes an oxidation, and specifically oxidation occurs at the alcohol, and it changed into aldehyde. So it means that the primary alcohol, upon undergoing the Swern oxidations, they change into aldehyde, and the secondary alcohols, I'm going to write another example where the secondary alcohol is reacting with Swern oxidation. Look at here. When this compound is reacted with DMSO, oxalyl chloride, triethylamine, and minus 60 degrees temperature, the same reaction conditions that I have described in above reaction, it undergoes an oxidation. We see here in this compound, we can see there are two alcohol groups. This one is secondary alcohol, and this one is primary alcohol. So upon reaction, we get this product. Primary alcohol changes into aldehyde, while the secondary alcohol, it changes into ketone. Now we will discuss the mechanism of this reaction. Mechanism. The mechanism of the Swern oxidation consists of two steps. The first step is the formation of chloro dimethyl chlorodimethyl sulfonium chloride. Your chlorodimethyl sulfoniamine, or you can call it dimethyl sulfonium chloride. Whatever it's easier for you to remember the formation of dimethyl sulfonium chloride. So I will describe mostly this intermediate, how this intermediate is formed. This is dimethyl sulfoxide. It has one resonance contributor. And what is that? When this pi electron density moves over the oxygen, you will get this. This is the resonance contributor of dimethyl sulfoxide. Remember, in the ozonolysis, I I had drawn there the resonance contributor of the ozone. It is a similar resonance contributor, so I should name it as a resonance contributor of DMSO. This resonance contributor of the DMSO, it reacts with oxalyl chloride. Oxalyl chloride. Oxalyl chloride, where the reaction would occur if this the resonance contributor of the DMSO attacks on the oxalyl chloride. What are the active sites? We know that this carbonyl group, it is it has partial positive and partial negative charge, because this is very polar, and this polar site is attached to two electron withdrawing groups. And what I'm saying that this keto group is attached to one chloride, it has negative inductive effect, and this is also attached to another group which has negative inductive effect. So that's why the electrophilicity of this carbon also increases. So this oxygen attacks on this electrophilic center, and when it attacks here, what happens? When it attacks here, then this chloride leaves, so you get this compound. The chloride which left in the first step, it attacks on this sulfur, this bond moves here, this bond moves here, and it leaves. So what you get? You get this species dimethyl sulfonium chloride, and carbon dioxide and carbon monoxide and chloride. I repeat that the resonance contributor of the DMSO, it attacks on the oxalyl chloride. The reaction occurs very rapidly. Why? Because the electrophilicity of the carbon is enhanced because of the presence of the two groups that have electron withdrawing inductive effects. So this oxygen attacks, leaving this chloride ion. You will get this intermediate, and the chloride which left from this auxiliary chloride, it attacks on this sulfur because this sulfur has a large positive charge on it, and this electron density moves here, here, and here. So we carbon dioxide and carbon monoxide and chloride, these are the byproducts. Now you can also ask that what is the driving force for the formation of this? What is the name of this? Dimethyl sulfonium chloride. Formation of dimethyl sulfonium chloride. This is very important intermediate that has now been formed in the first step, dimethyl sulfonium chloride. So what is the driving force for the formation of this? Actually, the reaction proceed in that direction where the entropy of the system increases. What is the entropy? Entropy means the randomness. Here you will see that we have only two starting compounds, but in the product you see 1 2 3 4. Now we are getting four different species. So randomness has now increased. It means that entropy has increased. So the reaction, this is the driving force of this reaction, that the reaction proceeds in that direction where the entropy is going to increase. So, and also when these gases, carbon dioxide, carbon monoxide, they leave from the system, the reaction further proceed in that direction, which will try to form these gases again. So this reaction, the formation of dimethyl sulfonium chloride, is very feasible here. So the first step of this mechanism is the formation of this species. The next step, attack of alcohols on dimethyl sulfonium chloride. Let's I take this alcohol. Let's just take a primary alcohol, and it's going to attack on this species, dimethyl sulfonium chloride. What will happen? This oxygen will attack on this sulfur because this hydroxyl group sees the large positive charge on the sulfur. What will happen next? So when this hydroxyl group attacks on this sulfonium, dimethyl sulfonium chloride, oxygen gets positive charge, and this hydrogen deprotonation occurs. Who will abstract this hydrogen? We know that in the reaction mixture there are many chloride ions, so they will abstract this hydrogen ion, or the deprotonation will occur, and you will get this what is the name of this species? What is the name of this group? This is alkoxy group or alkoxide. So alkoxy dimethyl sulfonium chloride. You will get this species. And what was the third reagent, the third chemical that we utilized in Swern oxidation? That is the triethylamine. So I should I should repeat here. Sorry. When this primary alcohol it attacks on this sulfur, here the chloride also leaves. So when this chloride leaves, the sulfur gets positive charge. This sulfur gets positive charge. No, it's right. Now next comes the role of this triethylamine. This is ET. What is this? Instead of writing the complete structure, this is triethylamine. So I am writing ET thrice N. What is the role of the base? This is a base. The role of the base is just to abstract the acidic hydrogen. Now see, where are the acidic hydrogen and which is the most acidic hydrogen in this species? Alkoxy, dimethyl, sulfonium. These hydrogens that are attached to the carbon which is further attached to the sulfur having positive charge. Both of these are the same. And these two hydrogens attached to the carbon which is further attached to the oxygen. These hydrogen are more acidic. So what will happen? This triethylamine will abstract one of the hydrogen from this methyl group. So when it will abstract the hydrogen, this charge will move on the carbon. You get when this charge the sigma electron moves on this the CH2 methylene group, carbon gets negative charge. What do you call this species? It's called yellow. A carbon yellow or sulfur yellow. What are the yellow compounds? Those compounds which have opposite charges on the atoms, and the carbon on the negative charge on the more electronegative element and the positive charge on the less electronegative element. So this species is called yellow. And the last, I can draw CH2 like this. CH single bond H. It attacks on this hydrogen. This bond moves here and this bond moves here. So you will get CH double bond O sulfur. When this pair of electron moves on this sulfur, they stabilize this positive charge. You get dimethyl sulfide on the two products. And what is the conformation of this step? Actually, this dimethyl sulfide, this compound is very smelly compound. So the minute concentration of the dimethyl sulfide, the human senses can detect that the formation of the dimethyl sulfide has now occurred. So finally we get this aldehyde. The reaction mechanism is very important. I'm going to repeat here. What is the Swern oxidation? The Swern oxidation is actually the conversion of primary or secondary alcohols into carbonyl compound. And what was the Swern reagent? It is a combination of DMSO, oxalyl chloride, triethylamine, and the reaction should be carried out at minus 60 degrees Celsius or even below that temperature. And what was the mechanism? The mechanism consists of two steps. The formation of the first step involves the formation of chlorodimethyl sulfonium ion. Dimethyl sulfoxide DMSO, it exists in two resonance contributors. This resonance contributor of DMSO, it attacks on oxalyl chloride. Why this attack on here? Because this C double bond O, this is highly polar. The carbon, the electron, this carbon is highly electron deficient owing to the presence of these electron withdrawing inductively withdrawing groups. So when it attacks on here, the chloride leaves, you get this. The chloride leaves in the first attack, it attacks on this sulfur. So this bond moves here, making a new bond between carbon and oxygen, so carbon dioxide is formed. When this bond moves here, carbon monoxide is formed and chloride leaves the system. What is the driving force for this reaction? I have already explained. The formation of this species is the first step, dimethyl chlorosulfonium or dimethyl sulfonium chloride. The formation of this species in the first step is important. In the next step, the alcohol, whether it's primary or secondary, it attacks on this species, dimethyl sulfonium chloride, and chloride leaves. When chloride leaves and the deprotonation occurs, you get this alkoxy dimethyl sulfonium ion. Then comes the role of the tertiary amine, a base. Base has to abstract a proton. Look into it. What are the acidic protons? You will see that these protons are more acidic. So this, it will abstract this hydrogen and charges the sigma electron moves on this carbon, making an ylide or ylide. Then this carbanion, which is nucleophile in sense, it abstracts this hydrogen. This bond moves here and this bond moves over here. So you will get dimethyl sulfide, a smelly like compound, and an aldehyde. I'm sure that you will get my point. Now I'm going to write a problem, and first I will solve that problem. The remaining problem will have to be solved by yourself. This is a problem that I took from Jonathan Clayton book. It is not 4-member, it is a 5-member ring. You can see this problem from Jonathan Clayton book. Sodium borohydride, THF. In the first step, then BPSCl in the presence of triethylamine, DMF, the second reaction. And the third reaction the third reaction is the Swern oxidation. You will have to reach the final compound. Let's suppose that compound is A. So students, what is the function of this sodium borohydride? In your previous classes or maybe in your lower semesters, you will have learned that sodium borohydride is a good reducing agent. It's a source of the hydride ion solution. Solution of the sodium borohydride. It's a source of the hydride ion. It's a reducing agent. What will happen? It will attack sorry, here it was a double bond. It will attack on this carbonyl carbon and bond moves on here. So you get this species. The first reaction is actually the reduction of this ester into aldehyde. In the next, because sodium borohydride is a good reducing agent, it will reduce this aldehyde into alcohol as well. So you will get this species. And in the next step, the B, it's what is the BPSCl? It's a biphenyl tertiary chloride. By BPSCl. It's a biphenyl silyl chloride. What is the structure of this BPSCl? Biphenyl tertiary silyl chloride or tertiary biphenyl tertiary silyl chloride. It's actually a protective group and it protects one of these hydroxyl. It it does not protect this this hydroxyl, because when it will attack on this hydroxyl group there will be considerable steric hindrance between the phenyl and the hydroxyl. So this OH, it will attack here and chloride will leave. You will get this species. And in the last, they have utilized the Swern reagent, Swern oxidation, and we know that Swern oxidation converts the alcohol into aldehyde. Now we have only one active site, that is alcohol, so the final answer will be this one. Now I am going sorry, I should actually repeat for you. What I feel is that you may feel it difficult to solve this problem. Actually, this is problem, I have taken this from the Claydon. This is your starting compound. Upon reaction with these reagents, you will have to reach your final product. In the first step, what happens? The sodium borohydride is a source of the hydride ion. The hydride ion will attack here, and this the sigma electron will move on the oxygen. Oxygen will get negative charge, and when the oxygen will get, it will abstract hydrogen, so it will change into alcohol. Aldehydes are in the presence of sodium borohydride, they changed into alcohol. You have learned this reaction in your previous classes. Then they have utilized this biphenyl silyl chloride. It's a protecting group of the hydroxyl group, and one of these hydroxyl group will react with this diphenyl tetrabutylsilyl silyl chloride. This hydroxyl group does not react. Why? If it attacks, then there will be considerable static hindrance will be there. This hydroxyl group attack, leaving this chloride, and this hydroxyl group is not protected. It cannot undergo this Swern oxidation. So when you will add this Swern reagent, one of the hydroxyl will change into aldehyde. Now I am leaving for you today with few problems that you will have to solve it by yourself, and here are your problems. Solve it and show me the answers on the WhatsApp. I have solved this problem for you. You will have to solve 1 2 3 4 5 6 problems. You will have to identify what are the reactive sites in case of Swern oxidation. You have to write the mechanism, you have to practice by yourself, you have to remember the Swern reagents, the reaction conditions, and your final products. Here you can see there are two functional sites, active sites, where reaction could occur. So what would be the products? And in the last, when you will solve these problems, this is another problem that I got from the Jonathan Claydon book. This is your starting compound. This is diisobutyl aluminum hydride. It is a reducing agent. It's also a source of hydride ion. It will reduce this ester. I'm giving you the hint. It will reduce this ester, and you will get this A compound. These are the Swern reagents. Upon this A, the Swern oxidation will occur on this A. You will get this B, and when this B will react with Grignard reagent, vinyl magnesium bromide, the final product I have drawn here, you will have to tell me what are A and B. So thank you so much. Allah Hafiz.